Today we are talking about the second day of our function notation. So this is function notation day 2. In today's, we are taking what we learned yesterday a little bit farther. So now we're actually going to connect in some of the things that we talked about previously. We talked about our dependent and independent variables. So for example, there was the one that said the width of an ice cream cone and the number of times it's been licked. And we had to identify which one of these is dependent and which one of these is independent. When we identify dependent, which you guys are pretty good at from talking to you, when we identify dependent, what we had to say was, well, which one of these is changed if the other one changes? Which one of these is changed because of the other one? So for example, with the ice cream cone one, it's pretty easy to see that the diameter is changed based on the licks. The licks cause the diameter of the ice cream cone to change. Well, what does that have to do with function notation? Well, these examples that we're doing right now are made pretty simple if we can identify which one is our independent and which one is our dependent variables. Once we do so, I'd put this, I know it's not on your paper, but I'd make sure I write it up in the top or one of the margins. What we want to do is we want to make sure that we write that and we put, well, X is always our dependent, so we put a D across the top, and Y is always our independent. And by that, I mean the complete opposite. Ugh, Mr. Meyer, get it together. Sorry if you just wrote that. I'll leave it in there. See if anybody brings it up to me. So f of x equals y. My x values are independent, and my y values are dependent upon whatever x value is plugged in. So make sure we have that up there with an I on the x and a D on the y, because my y values are dependent upon my x values. Okay, now let's take a look. It says here, let f of t be the outside temperature in Fahrenheit T hours after 6 a.m. Interpret the meaning of each statement. First, we need to identify what is our independent and what is our dependent. So which one of these things causes the other one to change? Hopefully, you said that the temperature is dependent upon the time. Temperature is dependent based on when the time changes, then that temperature changes. So if we think about that and we think about the f of x, what we're really saying here is we have a function that looks like this. F, which is just a name, of time equals temp. So we have a function called f, and when we put a time in it, out comes a temperature. Well, what is it about our time? So let's take a look at an example here to help us wrap our head around this. 0. What does that mean? Well, 0 is a t. I know that because it's in parentheses. It says t hours after 6 a.m. So basically, 0 hours after 6 a.m. What time is it 0 hours after 6 a.m.? It's 6 a.m. What does 58 mean? Well, 58 is what came out of this, which is a temperature. So 58 degrees Fahrenheit. So what this is telling us is that at 6 a.m., that's this part, the temperature is 58 degrees Fahrenheit. Now notice that this is there. Remember we talked in the last video, is and equals mean the same thing. Here we have one that's kind of like they're throwing two problems together. We have to figure out, okay, well, what does this mean? And then what does this mean? This one actually doesn't tell us a temperature. We're just kind of comparing two times. So this what comes out is a temperature, but we don't know what it is. So that's kind of goofy there. So what's this one mean? Well, f of 3, what does that mean? Well, 3 is t, so 3 hours after 6 a.m. So at 9 a.m., okay, so the temp at 9 a.m., what is this symbol here? It's less than, is less than, what does this represent? So 9 hours after 6 a.m. So that's actually 3 p.m. Notice how we took each piece of the phrasing and put it in there. Temp at 9 a.m. is less than the temp at 3 p.m. Here I have f of 6 equals n. We don't know what n is. You guys are used to seeing something like that. F of 6, that means 6 hours after 6 a.m. So 12, so noon. At noon, the temp is n degrees Fahrenheit. It didn't give us a number, so we leave that n as n. Okay, let's get to another idea. This one says, let n of t be the number of DVDs you have in your collection after t trips to the video store. Interpret the meaning of each statement. N of t. So now that's our f, so we're changing it up. This is not related to the n that we just did. N of t. Well, what is my input? What does t represent? T trips to the store. I'm going to put number of trips equals, well, what is the result? Well, that's the number of DVDs. Which makes sense because our number of DVDs is dependent upon the number of trips we took to the store. Just like up here, we said the temperature was dependent upon the time. The number of DVDs is dependent upon the number of trips. So 0 means how many trips, and number of DVDs is 8. After how many trips to the store? 0. 0 trips to the store, you have 8 DVDs. It's that simple. I'm just taking this and turning it into a sentence. This means 0 trips to the store. N is just a name. Ignore it. You have 8 DVDs. Here I have N of 3 equals 14. After how many trips to the store? 3. Oh. After 3 trips to the store, you have 14 DVDs. Here it says n of 5 is greater than n of 3. What does n of 5 mean? Here, n of 3 meant 3 trips to the store. Here, n of 0 meant 0 trips to the store. So n of 5 must mean 5 trips to the store. N of 3 must mean 3 trips to the store. Is greater than the number of DVDs after 3 trips. Just taking what's written there and rewriting it as a sentence. Okay, I want you guys to do this last one here, and then I'm gonna post the answers in a second here, and you guys can check to see how you did. So go ahead, pause the video right now. Actually, just do C and D. Okay, let's go through all 4 of these. So for number 3, we have A. It says, what is the cost of the appliance repair if it takes 8 hours? Hours is an X. So that tells me I'm going to rewrite my starting with 8s in the spot where the 2 X's are. The one on the left doesn't change. It's just the name of it. This right here shows me that we plugged in 8 and we got out 150. It's also easy to tell when I look at it this way that my dependent variable is 150, that's my cost, and my independent is 8, that's hours. If I look at B, it says, how many hours did it take to fix the appliance if the total cost was $193.75? The function c of x equals 1250x plus 50 represents the cost. That tells me that that's the big one. The outputs of this are cost. So I put 193.75 into the output location. It's like that's a y value. So we plugged it in and then we solved for x to get 11.5 hours. It's also nice to know that we're definitely looking for the x when it asks how many hours. X is the hours. C says interpret the meaning of C of 4 equals 100. 4 is an X, that's how many hours. So after 4 hours, the cost is $100. Same thing, after 0 hours, the cost is $50. Notice that this one doesn't really make sense, but we can still ask the question, what would it cost if it didn't cost any, or if it didn't take any time? It still costs 50 bucks. Your homework is actually a clever assignment for this one. Guys, got this. Appreciate how hard